chapter is not an attack on skepticism. It's a reminder that skepticism itself must be examined critically. The author argues that doubt is essential in science, but unexamined doubt can become prejudice. The double-edged sword of skepticism. Science depends on skepticism. Without doubt, fraud would go unchecked, weak evidence would be accepted, pseudoscience would thrive. But there are two ways to be fooled. One, believing what isn't true. Two, refusing to believe what is true. The chapter focuses on the second danger, the necessity of doubt. Good skepticism demands strong, repeatable evidence, improves experimental design, forces researchers to refine methods. And psi research has faced extreme scrutiny. Over decades, researchers tightened controls, eliminated flaws, used stronger statistics, conducted meta-analyses. Many early criticisms were addressed through better designs. Today, informed skeptics no longer argue that psi results are due to mere chance, that experiments are unrepeatable, that design flaws explain the effects. Those arguments no longer hold. The danger of extreme skepticism. The problem isn't skepticism. The problem is ideological skepticism. Some critics start from the belief that psi is impossible, then refuse to test it, then use rhetoric instead of research. Instead of conducting counter-experiments, many skeptics simply write critiques. This shifts skepticism from science to advocacy. The century of failure argument. Skeptics often say, after 100 years, psi has failed. But here's the author's counterpoint. Psychology itself still debates consciousness, memory, perception, awareness. After 100 plus years. Does that make psychology a failure? No. Understanding something fully and demonstrating it exists are two different things. Psi researchers don't claim to fully understand psi. They test reported experiences under controlled conditions. If the results consistently exceed chance, something real is happening, even if the mechanism is unknown. Valid versus invalid criticism. The chapter makes an important distinction. For criticism to be valid, it must be controlled. It cannot apply equally to all sciences. Testable, there must be a way to experimentally address it. Many common criticisms fail these tests. Examples of invalid criticisms. There have been fraud cases. Fraud exists in all sciences. There is no theory. Many accepted phenomena lacked theory for decades. Effects are small. Many revolutionary discoveries began with small effects. The only truly valid criticism. Have there been independent replications? And according to the author, yes. Media distortion. Another major issue is how psi research is portrayed. News articles often mention criticisms, fail to report that those criticisms were tested and resolved, imply flaws without showing they exist. This creates a public image that psi research is careless, even when studies meet rigorous standards. National Research Council controversy. One major example discussed. A 1987 report by the U.S. National Research Council concluded there was no scientific justification for psi. However, no active psi researchers were included on the committee. Positive evidence was downplayed. Internal contradictions appeared in the report. Some commissioned reviewers actually found strong results. Public statements didn't fully match internal findings. This illustrates how public opinion, politics, and reputation can influence scientific debates. What the debate has really shifted to. Today's debate is no longer about, are the results statistically real? Even some skeptics admit the results are astronomically significant. The debate is now about interpretation. Skeptics acknowledge something unusual is happening. They just refuse to call it psi. Core message of the chapter. The real lesson is not believe in psi. It is apply skepticism to everything, including skepticism itself. Science is healthiest when evidence is tested, criticism is fair, and no one starts with a fixed ideological position. Extremes on both sides, blind belief and blind dismissal, distort truth. Real science lives in the middle. Final takeaway. This chapter argues that psi research is controversial not because there is no evidence, but because it challenges deeply held assumptions. And when assumptions are threatened, even scientists can become defensive. The chapter invites readers to step back and ask, are we rejecting evidence because it's weak or because it makes us uncomfortable? That question is bigger than psi. It applies to all of science.